Okay, so good evening, everybody. So I want to discuss related to electrochemistry. So it is useful for weekend examinations. Yes. So electrochemistry. First, we divide the parts present in the electrochemistry. Yes. Divide the parts in electrochemistry. First one, Faraday's laws of electrolysis. Next, the concept is Nernst equation related, and the part conductance. So these are the main three terms present in the electrochemistry. First, we discuss related to electrolysis. So electrolysis, in that we are discuss the concept Faraday's laws, Faraday's first law, Faraday's second law, like that. So we are taking the Faraday's first law, Faraday's first law. Faraday's first law, what he explained, the amount of the substance deposited at respect to electrode is directly proportional to quantity of the electricity. For example, you want to do certain work, for example, in your home, so you want to work one bulb, so one tube light you want to work. A little battery which is used for wall clock, that battery take the two electrical wires and apply to this tube light, it can't work out. Why? So the minimum quantity of electricity for to work the tube light is not enough for that voltage what to generate from small battery. So the amount of the substance deposited on the electrode, respect to electrode, is directly proportional to the quantity of the electricity what is supplied. Suppose he supplied 1 Faraday electricity, 1 Faraday related substance only deposited. Sir, you are told deposited means what, sir? For example, if you take fused NaCl, it consists of Na plus and Cl minus. Okay. So when 1 Faraday electricity is passed through the fused NaCl, 1 Faraday electricity is passed through the fused NaCl, in which Na plus Cl minus ion there. So when electricity is passed through the fused NaCl, Na plus ion is goes to cathode, and Na plus ion is goes to cathode and deposited on the respective electrode. Cl minus ion goes to anode and deposited on the respective electrode. So therefore, the amount of the substance sodium deposited on the respective electrode is depending on the passing electricity. Suppose you pass the electricity is 1 Faraday, yes, you observe this reaction? Yes. Na plus ion gain 1 electron, it converted to Na solid. That means to deposit 1 mole of sodium, 1 mole of electrons required. 1 mole of electrons, the charge is calculated. 1 electron charge 1.6 into 10 power minus 19 coulomb. 1 mole of electron charge you calculate, that is 96,500 coulombs. That is nothing but 1 Faraday. Okay. So 1 mole of electrons, the charge becomes 1 Faraday. 1 Faraday electricity is supplied through the sodium. The deposited weight over 23 grams. Now Faraday's laws, what I explained? The weight of the, yes sir, good evening. So the weight of the electrolyte deposited on the respective electrode is directly proportional to the quantity of electricity. If you supply 1 Faraday, 23 grams deposit. If you supply 2 Faraday, 46 grams deposit. Sir, I will supply 0.1 Faraday, sir. Then at the time 23 comes. No. Supply little amount of electricity, little amount only deposited. Yes, based on this equation, 1 mole of electron, nothing but 1 Faraday. 1 Faraday gives 23 grams. 0.1 Faraday gives 2.3 grams. Like that. So therefore, finally, the amount of the substance deposited on the respective electrode is directly proportional to the quantity of electricity. Okay. So to deposit 23 grams sodium, 1 mole of electron required, nothing but 1 Faraday required. If you supply 1 Faraday, yes, 23 grams deposited. If you supply 0.1 Faraday, 2.3 grams only deposited. Yes, sir. I will, yes, sir. Good evening. Harini, good evening. So, Kritika, good evening. So, next, then the supplied electricity, if you supply 1 Faraday electricity through the sodium, yes, we got the value 23 grams deposited. If you supply 1 Faraday electricity through the magnesium, 12 grams only deposited. Why it is 12 grams? Same, sir, same logic. Here I will explain. Mg plus 2 electron gives rise to Mg. That means to deposit 1 mole of magnesium, the current required is 2 mole of electrons, nothing but 2 Faraday. 2 Faraday gives 1 mole, means 24 grams. So therefore 1 Faraday supplied, how much will come, sir? Yes, that atomic weight what you get by the charge, that is 1 Faraday. So therefore any substance you take, 1 Faraday electricity is passed through the any substance, the deposited weight is equal to its equivalent weight. Here the new word came, equivalent weight. 1 Faraday electricity is passed through the any substance. Sir, any substance? Yes, sir, any substance. 1 Faraday electricity is passed through the any substance, that is H plus, Na plus, Mg plus 2, Al plus 3, O minus 2, okay, Ag plus, copper plus 2, Zn plus 2, anybody. 1 Faraday electricity is passed through the any substance, the deposited weight at the respective electrode. Respective electrode means the cathode, anode, that story I have already explained. Once again I will explain. So on the respective electrode, the deposited weight is equal to its equivalent weight. So Mg plus 2 equivalent weight 24 by 2, 12 grams. Al plus 3 equivalent weight 27 by 3, 9 grams. Oxygen, the deposited weight of, sir, oxygen formula O2, sir. So to get the O2, how much Faraday required? So O2 correct only, but O2 coming from oxide ion, O minus 2. So therefore O minus 2 charge minus 2. That means to deposit 1 O, just 1 O, 2 Faraday required. But 1 Faraday supplied 16 by 2, 8 grams. So 8 grams oxygen. Sir, 8 grams oxygen means adi O na, O2 na. Yes, what you convenient like that you write. 8 grams O deposited means, so 8 grams O2 also deposited. Okay, oxygen gas is deposited 8 grams. So very excellent and outstanding bit, sir. Suppose 1 Faraday electricity is passed through the hydrogen, deposited weight calculated 2 grams, sir. 1 gram means hydrogen coming from H plus. So H atomic weight 1, charge 1. So therefore equivalent weight 1 gram. So to deposited 1 gram of hydrogen, the required current 1 Faraday. To deposit 8 grams of oxygen, deposited current 1 Faraday. The same thing if you applied into the volume, yes, very excellent bit. If 1 Faraday electricity is passed through the, H plus, How much volume deposited on the cathode means, yes, first convert weight, sir, then automatically based on the mole concept you find the volume. Yes, 2 gram hydrogen 22.4 liters at STP, 1 gram hydrogen only deposited 11.2 liters at STP. Now the logic questions are excellent and outstanding question. Hydrogen deposited weight 1 gram. Hydrogen volume converted 11.2 liters came. Therefore, same 1 farad electricity passed through the oxide ion or OH minus ion, at anode oxygen gas liberated. How much volume of oxygen liberated at anode? How to determine, you know? Yes, same concept. 1 Faraday electricity is passed through the oxide ion. 8 grams oxygen only deposited, sir. So 8 gram oxygen volume we want to convert. 32 gram O2 is the molecular formula. 32 grams 22.4 liters. 8 grams means 5.6 liters only. So therefore, can you explain? 1 Faraday electricity is passed through the acidulated water. What is the volume ratio of hydrogen and oxygen at cathode and anode respectively? Means, yes, 1 Faraday electricity passes through the acidulated water means pure water is a bad conductor. That is why we take acidulated water. H plus and OH minus will come. H plus reduced at cathode. 1 Faraday supplier, 1 gram only deposited, 11.2 liters. 1 Faraday supplier, oxygen, 8 grams oxygen gas only deposited at anode. That is nothing but 5.6 liters. That is the story. So then oxygen is considered 8 grams. In water is passed 9 grams water deposited, or 9 grams water electrolyzed. 9 grams water electrolyzed means water H plus OH minus there. So H plus 1 gram O, oxygen related information 8 grams. Total 9 grams electrolyzed by passing 1 Faraday electricity through the water. Next, this is a very excellent information. So therefore, finally, I will introduce once again what is Faraday's first law. What is first law? The amount of the substance deposited at the respective electrode is directly proportional to the quantity of electricity. So observe it. What I told, 1 Faraday passed the electricity. These are the deposited weights. Sir, quantity increases. Yes, the weights will increase. Quantity decreases, the weights will decrease. Therefore, this is only the Faraday first law. The amount of the substance deposited on the respective electrode is directly proportional to quantity of electricity. So that implies W is equal to some constant, proportionality constant, small e into C into T. W is equal to ECT. What is C and T means? So now, sir, I will read Q is equal to IT, sir. Yes. What you read like that? Q is equal to IT, current into time. So now here, what is small e? Small e is called electrochemical equivalent. Small e is called electrochemical equivalent. Small e. Yes. So small e is called electrochemical equivalent. That is equal to capital E by 96,500 into I into T. That is the weight of the electrolyte deposited. Weight of the electrolyte deposited at the respective electrode is directly proportional to quantity of electricity. That can be converted like this. Okay. Now, here very important, very excellent important. From outside, from the outside, some electricity is entered into your house. What the electricity comes to the house, that all can't be used. Some part only. Some part of electricity used for tube light, some part of electricity used for fan, some part of electricity used for fridge, some parts of electricity for geyser, some different. Okay. Still some source there, some there. Like that, what the electricity is passed through the electrolyte, total total utilizer, not utilizer, we don't know. That is why here the given efficiency of the current given in this problem. Efficiency, they are given the problem. Yes, I passed 2 farad electricity through the copper sulfate, sir, but in which 80% only efficient. So therefore, I will change the formula. Yes, W is equal to capital E by 96,500 into this I into, okay, percentage of efficiency, eta, into time. This is the formula. So 80% efficiency means that percentage 80 by 100. Current, so you are passed the current 2 ampere current. On that 80% only utilized. So 2 into 0.80 by 100, 0.8. Okay. Now, in this formula, very important words are I into T. I must be in ampere, T must be in second. That is a very important logical question. I must be in ampere, T must be in a second. T must be in second. If they are given minutes, hours, days, is convert into seconds. Okay. So because we want coulomb, sir. We want coulomb. This is the related term, entire term is related to 96,500 coulomb is called 1 farad, I already told. Coulomb story want ampere to second only indicates the coulomb. Is it clear? So therefore, W is equal to equivalent by 96,500 into I into percentage of efficiency into time. T must be in second. I must be in ampere. Efficiency, that is 80% or 70% or 60% or based on that, right? Later, what is E? E means gram equivalent weight, sir. Gram equivalent weight. Yes, I already told. If we pass the electricity is 1 Faraday, nothing but this term how much, sir? 1 Faraday. 1 Faraday means 96,500. This 96,500, 96,500 cancel, W is equal to E. Okay. So, this is the very excellent and outstanding formula related to Faraday's first law. Now here, I will introduce electrochemistry with stoichiometry. Electrochemistry with stoichiometry I will apply. Yes. Yes, here we observe equivalent weight in the numerator. Weight is there in the left side. That equivalent comes to left side, it comes down, the formula comes like this. The formula comes like this. This is the formula. Weight by gram equivalent weight is equal to I into percentage of efficiency into time by 96,500. So what is weight by gram equivalent weight, sir, as per stoichiometry? Gram equivalence. So gram equivalence is equal to I into T by 96,500. That I into T, I means mostly 100%. Any information not given related to percentage of efficiency of current taken as 100%. Okay, information is not given. So weight by gram equivalent weight is what, sir? Gram equivalents. So number of gram equivalents, one equivalents there or other equivalents. So the gram equivalents can also be write in the terms of normality. So same formula, normality into volume in liter. Normality into volume in liter is equal to I into percentage of efficiency into time by 96,500. This is one more formula related to same, sir, same. The problem is not given in the terms of weight and equivalent weight, sir. The problem is given in terms of normality and volume. Yes, equate. Because we know number of gram equivalents is equal to weight by gram equivalent weight or normality into volume in liter or moles into N factor is equal to I into percentage of efficiency into time by 96,500. Yes, this is one more formula. Yes, you observe this formula. It is a very beautiful comparison related to electrochemistry and gram equivalent concept of stoichiometry. Yes, it's applied based on the problem you involved, then automatically got the ideas. Yes, this is Faraday's first law. Then we are going to Faraday's second law. Faraday second law almost look like a Faraday first law only. What they told? What they told? Question like what they told? Yes. Same quantity of electricity is passed through this side and that side. Same quantity of electricity is passed through this side and that side. The weight ratio is equal to gram equivalent weights. For example, I pass 1 Faraday electricity through the copper sulfate. I pass 1 Faraday electricity through the AgCl. Same current passes through the two different sources. Therefore, the weight ratio of the respective electrode is directly proportional to their equivalent weight ratio because quantity of electricity is same. Therefore, W1 by W2 is equal to E1 by E2. W1 by W2 is equal to E1 by E2. This story when will be correct, sir? Yes. Quantity of the electricity is the same for the two electrolytes. So W is equal to capital E by 96,500 into Q na. Q means W proportional to E1 only na. W2 proportional to E2 then W1 by W2 is equal to E1 by E2. That is called Faraday's second law. Okay. Now we are going to the one more concept, the same formula, one more concept, sir. Atomic weight, how to calculate using the Faraday first law. You wrote W is equal to capital E by 96,500 into I into T into percentage efficiency in time. What is E, sir? Yes, nothing but gram atomic weight by N factor. Gram atomic weight by valency or N factor, like that. Okay. So therefore, if you know the gram equivalent weight using that formula, by using that atomic weight can be calculated using valency. Equivalent weight is equal to gram atomic weight by N factor or valency. That is the story, Faraday's first law. Next, sir, excellent bit. So, one particular electrolyte, sir, which one deposited, how much deposited, Faraday will explain, sir. But I pass the electricity through the fused NaCl. Sir, Na plus Cl minus 2, one cation, one anion there, sir, cation goes to cathode, anion goes to anode. Okay, sir, good, sir, excellent, sir. But what about aqueous NaCl, sir? Fused NaCl, Na plus Cl minus 2 only there. So one goes to cathode, one goes to anode. So excellent. But if you take aqueous NaCl, there is a problem. Aqueous NaCl consists of Na plus water, Cl minus water, like that. So that means there is a competition present between Na plus and H plus. There is a competition present between Cl minus and OH minus. So you will go to, hello Mr. So please sir, what sir, chapati, what is that? Unnecessary comments don't take, sir. This is damage will come. Okay, you are not interested, better to leave. Okay, don't take unnecessary comments. Okay. Because it is YouTube channel, this is not in Bangalore people's are seen. It is just observing an entire world. Clear? So therefore damage will happen. So if you want to comment, good comment, yes, comment it. No, otherwise bad comment, yes, comment it. But don't take chatting with your friends in this dais. Okay? So good. If you are, yes, teaching is bad, yes, better to comment. Teaching is good, yes, better to comment. That is good. So because it is not in Bangalore team, just particular area, particular college, not like this. The world, the entire world can observe. Yes, very good. So then, very kind information. Yes, sir. Fused NaCl taken Na plus Cl minus will react. Good, sir. Excellent, sir. But aqueous NaCl taken, sir, Na plus water, the two are competition, sir. Cl minus OH minus, the two are competition, sir. Then what what you take? Yes, I will give the very beautiful story. If two cations are in comparison, the cation which possess more standard reduction potential will go to cathode first. Here, very excellent point. First, sir, only go to that ion only, that is wrong. Okay. For example, if you pass aqueous NaCl electricity through the aqueous NaCl or brine solution, water undergo reduction first instead of Na plus. Reason? H plus SRP value plus 0.00 volts. Na plus SRP value minus 2 point something. Clear? So that means in these two cations compare, the cation which has more SRP undergo reduction first. The cation which has more SRP undergo reduction first. So, sir, then SRP order by hearting required? No. Just now, majority of the students, okay, you are completed D block. D block, you observe 3D series, entire 3D series low only copper only positive SRP. Remaining all are negative SRP. Like that, entire D block or entire chemistry, CHAPA elements called CHAPA, shortcut CHAPA, metal ions possess more SRP, standard reduction potential is very high. Due to the high standard reduction potential, they readily undergo reduction first instead of H plus, because they have positive SRP. H plus value how much given? Plus 0.0. When compared to that, that is more. So clear? So therefore, aqueous NaCl, which ion undergo reduction first means, yes, Na plus ion, H plus means H plus ion undergo reduction first and gives hydrogen gas at cathode. Sir, from starting onwards, you are doing one word, sir. First, you told, sir. First means this one, next Na plus will come, sir. Yes, sir, correct. Na plus comes. When will become, sir? Yes. Suppose you are taking 3 Faraday electricity, but in your solution, 1 molar H plus ion only there. So clear? 1 molar H plus ion only there. Therefore, when 3 Faraday electricity through the 1 molar H plus, 1 Faraday is enough. 1 Faraday enough to complete a reduce of H plus ions. Still, how much current there, sir? Still 2 Faraday electricity there. Suppose all H plus ions are reduced by passing your 3 Faraday current, still current there, still the H plus ion not there. Therefore, at that time, obviously, who are there in other cation that only undergo reduction? That is Na plus. So clear? That is why aqueous NaCl H plus only reduce at cathode, that is wrong, sir. H plus only reduce at cathode, wrong. H plus is first reduce. Preferential discharge theory. Preference. We are giving preference. So here, somebody are joining. So nearly 48 members are joined. 49 members are joined. So then, these all members starting who are joined at 8:30, that all are preference. 100% they have preference there, because they are first point to last point they are listening. Who are joined just for time pass, just joining, leaving. So there is no use. Clear? So like that, preference discharge theory means more SRP ion first reduced, later second SRP. Isn't it? That is the story. Now, sir, fused NaCl lo Na plus deposited cathode, Cl minus deposited anode. Aqueous NaCl lo water undergo reduction first instead of Na plus. Therefore, hydrogen gas deposited cathode. Now anode story, sir. Anode. Yes, same story like this only explained. Cathode lo high SRP undergo reduction first means anode lo Low SRP anion undergo oxidation first. Low SRP anion undergo oxidation first. Sir, okay sir, cations lo you are given the story chapa, but like that anions also some story there. Yes, anions lo aqueous solution of anions. If you take phosphate, sulfate, nitrate, fluoride, if these four ions there in the aqueous solution, OH minus ion undergo oxidation and gives oxygen gas at anode. If other ions, if aqueous solution lo, if other ions are present except OH minus, if any other anion is present, that another anion only undergo oxidation. If aqueous solution consists of OH minus ion and sulfate, OH minus ion undergo oxidation. If aqueous solution consists of OH minus ion and phosphate, OH minus ion only undergo oxidation. If aqueous solution consists of fluoride ion and OH minus ion only undergo oxidation. If aqueous solution consists of OH minus and Cl minus ion undergo oxidation. That is the story. Aqueous NaCl why chlorine. Recently we have done in 17th group how chlorine is prepared by Nelson cell process means. This is the story. Aqueous NaCl you are taking brain solution is taken as electrolyte. But why chlorine deposited anode? Why can't be OH minus? Yes, that is the story. Less SRP ions readily undergo oxidation first when compared to here also first means depending on the current. Okay, that is the story. Which ion undergo oxidation, which ion undergo reduction at cathode. It's clear. Now, sir, here exceptions are there. Yes, sir. If in exceptions we take very concentrated NaCl, very dilute NaCl, and that the story SRP concept not be work out. Very concentrated NaCl, very dilute NaCl. Very concentrated NaCl meaning sir, water little amount there. Very aqueous diluted NaCl means water more amount there, NaCl little amount there. That story will be different. Okay, first we will discuss about which ion deposited at cathode, which ion discussed at anode. Now, fused copper chloride, copper undergo reduction, chlorine undergo oxidation. Aqueous copper chloride, copper undergo reduction. Why copper undergo reduction? Aqueous. Sir, previous aqueous NaCl low, water undergo reduction you told sir. Again, why you change sir? Aqueous copper chloride low, copper undergo reduction you told sir. Why sir, you give different manner? Yes, I already told. Chapa metal ions are there in aqueous solution. That metal ions only undergo reduction first because they have ISRP. So that is why copper undergo reduction at cathode. If you take, aqueous solution. So next story, sir. This is a story. Cu has a positive SRP. Yes, correct. Copper has a positive SRP is the correct answer. So that is why it undergo reduction first. That is the story SRP. Next story, sir. Next story. It is the Faraday's first law and the Faraday's electrolysis. Briefly, I will explain. Briefly. Because I want to explain electrochemistry a majority of the part today only. That is a brief introduction done. Next, we are going to SRP, SO2. Yes, those members are very perfect in the D block and P block. Okay, that members the story is very easy. Even though I will explain again. In the entire electrochemical series, if you write the series of all the elements, so electrochemistry now, what the elements are there, if you write all the elements electrochemical series, lithium is the toppest position, F is the lowest position. A series low. Sir, toppest to lowest means based on increasing or decreasing what you wrote, sir? Yes, sir. I wrote lithium is the least means, lithium is the top position means lithium is the least SRP. Standard reduction potential comparison is series, sir. In this series, Lithium is the least SRP, fluorine is the first SRP. First means highest. First SRP is fluorine, lithium is the least SRP. Is that clear? So therefore, lithium undergoes reduction. Here so much clarity required, sir. So in entire all the cations, I compare only the two. One is lithium, another one fluorine. Clear? Lithium is the least SRP, fluorine is the first SRP. Lithium is the least SRP, fluorine is the first SRP. So least SRP, previously electrolysis also what I told, lithium is the least SRP means lithium undergoes oxidation readily. Sir, I have a doubt, sir. Reduction means, I have no idea, reduction means gaining of electron. Li gain electron, Li plus gain electron. That I have a doubt, sir. Yes. Your doubt is correct, sir. Li plus, sir. Li plus gain electron and convert it to Li. That means Li plus reduction is negative. Fluorine F minus reduction not come. F or F2. F2 gain electron and convert it to F minus. That is reduction. So reduction of F2 is positive. Reduction of Li plus negative. So those elements possess least SRP that undergo oxidation first. Those elements possess least SRP that elements undergo oxidation first. Those elements possess highest SRP that elements reduction first. So clarity. So lithium undergoes oxidation readily. Lithium or Li plus. Clarity, sir, everybody? Li undergo oxidation, Li plus undergo oxidation. Clarity. Clarity, anybody? Type it. Li undergoes oxidation. So you are observing the running. Then you can use a like, sir. Like symbol means it can go to all members. I told already it is India. India-wise, Indians observed. Yes, what they interest in other countries, that members also observed. Okay. So therefore, very good. Majority of the members answered Li wrong, madam. Who are answered Li? That is wrong answer. Tanushree, why, madam? Okay, Li is wrong answer. What I told, first of all, what is my question? Which element undergo oxidation? Yes. Who are answered finally? Which element undergo oxidation? Li. Yes. Li undergoes oxidation. Li undergo oxidation first. Li plus undergo oxidation wrong. Li. Yes. Tanushree, what the given answer is the correct, Nana. Li undergoes oxidation. Lithium undergo, not Li plus undergo oxidation. Lithium undergoes oxidation readily. Therefore, lithium acts as a reducing agent, not Li plus. Okay, Li plus not act as a reducing agent. Lithium element undergo oxidation readily because Li plus reduction least value means Li readily undergo oxidation. So lithium acts as a powerful reducing agent. F2 acts as a powerful oxidizing agent. F2, fluorine acts as a powerful oxidizing agent. That is the story. Okay, based on that, if you compare any two among the following, which is a spontaneous reaction, which is a non-spontaneous reaction, means a reaction lo only one thing you observe. Highest SRP lithium element alone undergoes oxidation readily. Very good. Answer. Your answer is correct. So lithium element readily undergo oxidation. Correct. Excellent. So now what I am explaining, the part power. Next what I am explaining, the reaction among the following which is spontaneous, which occurs, which feasible means check the two elements in the reaction. The lowest SRP oxidizer, lowest SRP reducer, that you check. So pair lo lowest SRP oxidation like highest SRP cation reducing like that reaction there, that is a correct reaction. Almost other reactions are wrong. That is spontaneity. Okay, this is about very excellent information related to oxidation and reduction, SRP, SOP concepts. Now the very excellent and outstanding concept, Nernst equation, very much important. Nernst equation lo E of the cell is equal to E naught of the cell minus 0.059 by n into log of concentration of product by reactant. Yes, sir. How you got that reaction, I will explain very simply. Yes, sir. This is the reaction. So consider a reaction A plus B gives rise to C plus D. As per thermodynamics, delta G is equal to delta G naught plus 2.303 RT log Q. This is a formula, delta G formula. Delta G is equal to delta G naught plus 2.303 RT log Q. This formula is used for chemical equilibrium. This formula is used for thermodynamics. This formula is used for electrochemistry. Now we are doing electrochemistry. Yes, electrochemistry. Lithium. Somebody wrote lithium. Still, why again you are typing? Leave it that one. So delta G is equal to delta G naught plus 2.3 RT log Q. Delta G I want to convert in terms of electropotential. Yes, this formula is minus NFE. This formula is minus NFE naught plus 2.303 RT log Q. Q means Q only. So this formula converts E is equal to E naught of the cell. This formula minus the comes this side 2.303 RT by NF. That is simplification 0.059 by N into log Q. Q means concentration of product by reactant in the reaction cell. In the reaction, what the reaction there? The AB reaction, Cu plus 2 reaction, whatever it is. Concentration of product by concentration of reactant, Q. Okay. Now this is the point Nernst equation. In this Nernst equation, on ultimate point, what's that? E naught of the cell how to calculate. E naught of the cell. Simply they are given oxidation cell. Simply they are given oxidation. Then E oxidation is equal to E naught of oxidation only take. That reaction product by reactant substitute. Simply they are given reduction. E reduction potential is equal to E naught of the reduction take. Oxidation and reduction simultaneous, both are given in a particular entire reaction. Therefore, two combination of the reaction law, how to calculate E. In that the major point E naught of the cell. Okay. Very excellent point. E naught of the cell is cathode and anode sum value. E naught of the cell is entire. Very kind information. E naught never be changed with the stoichiometry. You are multiplying with 2 cell. You are dividing with 2 cell. Whatever it is. F2 plus 2 electron gives rise to 2F minus E naught value plus 2.81 there. 2.87 there. Half F2 plus 1 electron gives rise to F minus also same value, sir. E naught never be changed. Sir, I multiply with 2, I multiply with 3, E naught not changes, sir. Yes, E naught never be changed. E naught is a standard electrode potential, is a fixed value for a particular metal ion conversion. But E will be changed with the N. With the N, E will be changed. So E is equal to E naught, and here N there. The N with the N changes E, but not E naught. E naught not be changed with the N. So clear? Now, E naught of the cell calculate like this. E naught of the cell is equal to E naught cathode SRP minus E naught anode SRP. Sir. Cathode SRP minus anode SRP E naught of the cell. Okay. So by using this one, you calculate. Okay, this is a brief discussion. Okay, sir. So, so try it. So do it problems. So I close my meeting. Okay, bye. Okay, thank you very much.